Okay, today we're going to do more fundamental theorem of calculus, where we take antiderivatives and we plug in the upper and lower values of our limits to figure out our total value. So this first one, I maybe should rewrite it as x squared plus x to the 1/2 dx, and I get 1/3 x cubed plus, you get x to the 3/2, and reciprocal of that is 2/3, and I'm evaluating from 0 to 1, and I plug in 1, I get 1/3 of 1 cubed plus 2/3 of 1 to the 3/2, and that is my upper, minus when I plug in 0, I think it's obvious I'm going to get 0. Upper minus lower every single time. And I get 1/3 plus 2/3 minus 0, and my final result is just 1. This next one I should rewrite also. Just split it up into two fractions. 1 over the square root of x minus the square root of x over the square root of x. And if I really clean it up, I get x to the negative 1/2 minus 1 dx. I take its antiderivative, and I get 2x to the 1/2 minus x. And I'm going to plug in 0 and 4, and when I plug in 4, I get 2, 4 to the 1/2 minus 4, minus, I think it's obvious when I plug in 0, I get 0. And if I look at this, 4 to the 1/2 is 2, so I get 4 minus 4. So my whole result is 0. So if I would ever look at this function, if I would graph this function, this original function, it would have to be a function that whatever area was above the x-axis was exactly the area below the x-axis. That's the only way you can get x equal to 0. Oh, some trig functions. Well, let's see, the inverse of sine is negative cosine of x, plugging in 0 and pi, and that would be negative cosine of pi minus negative cosine of 0. Cosine of pi is negative 1, so negative 1 would be 1, minus cosine of 0 is 1, so minus negative 1. So I get a final result of 1 plus 1. So this is 2. So what is this saying? If you can remember what the graph of sine looks like from 0 to pi, it looks like this. It is saying that this graph has area equal to 2. In my last example, I get 2x minus ln of x evaluated from 1 to e, and I plug in e, I get 2e minus ln of e. That's my upper, minus my lower, which is 2 times 1 minus ln of 1. That's my lower, so always upper minus lower. Well, ln of e is just 1, so it's 2e minus 1 minus, well, ln of 1 is 0 minus 2, and I get a final result is 2e minus 3. We'll put that in the calculator. You get about 2.4366. Okay, the next example, I'm going to move it this way. I got to flip up for a second. And I'm going to minimize this. I'm going to find my So I want to find the area between this parabola and the x-axis. I need to know the x-intercepts. That means I should factor it. I'm going to divide everything by -1 and set it equal to 0. So x squared plus x minus 6 is equal to 0. Or x plus 3, x minus 2 is equal to 0. I get my x-intercepts as -3 and 2. So this graph should look like this. -3, 2, it will look something like this. And we are trying to find this area. So to find the area, I do a integral from -3 to 2 of -x squared minus x plus 6 dx, and I get -1/3 x cubed minus 1/2 x squared plus 6x, evaluated from -3 and 2, and now I just plug in my upper and lower. Plug in my upper first, -1/3 2 cubed minus 1/2 2 squared plus 6 times 2, minus, now my lower, -1/3 -3 cubed minus 1/2 -3 squared plus 6 times -3. Let's plug in the upper and the lower. And I tend to use my calculator for this, but you could do the computation for this all. I get equals 22 over 3 minus -27 over 2. And when I put this all in the calculator, I get 125 over 6, or 20 and 5/6. So the total area is equal to 125 over 6. Okay, going back to the last problem, this red is the graph of that last problem, and we just found out the area was 125 over 6. Archimedes, lived a long time ago, figured out that this area is 2/3 base times the height, or 2/3 of the circumscribed rectangle. So the base, this goes from -3 to 2. So this base right here is equal to 5. That's obvious. Now the height is at the vertex. Well, the x part of the vertex is in the middle of this. My vertex is going to be at -0.5. I plug that into this equation. I find the y part of the vertex is 6.25. So this point right here is -0.5, comma 6.25. So the height is 6.25. So like I said, my vertex was -0.5, 6.25. Now if I want to figure out the area, well, is this area in red 2/3 base times height? Well, let's see, what's 2/3 times 5 times 6.25? And let's see, 2/3 times 5 over 1 times 25 over 4, and I multiply this out, I get 250 over 12. So this area, doing Archimedes' little formula, is 125 over 6. And wow, it is exactly the same area. It's 2/3 of that rectangle. Okay, so now I want to find the shaded region here. I notice I have two curves. I have split in half. I have region 1 and region 2. Well, can't even spell. So the total area is equal to region 1 plus region 2. Well, region 1 is the integral from 0 through 1 of x squared dx, plus in region 2 is an integral from 1 to 2 of 2 minus x dx. So all I have to do is take their antiderivatives. Well, this is going to be 1/3 x cubed evaluated from 0 to 1 plus this will be 2 minus 1/2 x squared evaluated from 1 to 2. And I'm going to plug in the numbers. Equals, well, I got 1/3 of 1 cubed minus 1/3 of 0 cubed. This is region 1 plus, now this one I have to do a couple things here, so it's going to be, I'm sorry, this is 2x, my bad, 2x. So I'm going to plug in 2 here. I'm going to get 2 times 2 minus 1/2 of 2 squared. I got to put that all together because that's my upper. Minus, I'm going to plug in 1. 2 times 1 minus 1/2 times 1 squared. And everything in black is region 2. Like I said, this is my upper minus my lower. And I put this all in. I get this is 1/3 minus 0 plus, let's see, 4 minus 2 plus 2 minus this is 2 minus 1/2 minus 3/2. I put this all together and I get 2 1/3 or 7/3 minus 3/2. I get 5/6. So this whole region, the red and the blue region together, is equal to 5/6. Which kind of makes sense because if you look at it right now, if you do this whole rectangle, this rectangle is 2 by 1, it's 2, and this shaded region is probably about a little bit less than half of that. Okay, a little bit harder problem. I need to figure out this shaded region right here. Well, I think I have to do some addition here. So I have if I look carefully, I have a blue region. So I can say the blue region is equal to the shaded region plus I also have this red rectangle plus this red region. Well, the red region is the easiest one to figure out. That's just a rectangle. Area equals base times height. And this base is this length here. The base is 5 pi over 6 minus pi over 6, which is 4 pi over 6. So my base is equal to my base is equal to 2 pi over 3, and my height is this value right here, is equal to sine of pi over 6, was equal to a half. So the area of the red region is equal to 2 pi over 3 times a half. So this area of the red is equal to 1 pi over 3. Okay, so I know that. If I want to solve for the shaded region, I could rearrange it and do my shaded region is equal to my blue region minus the red region. And now this blue region is this whole big integral from here to here. So the blue region is going to equal the integral from pi over 6 to 5 pi over 6 of sine of x dx. That's what we've been working on. So my shaded region is going to be the integral of sine of x dx from pi over 6 to 5 pi over 6 minus this red region, which I just figured out was pi over 3. My shaded region. So this is going to equal, well, this antiderivative is cosine of x evaluated from pi over 6, 5 pi over 6, minus the red region of pi over 3. Well, it's negative cosine. So I get negative cosine of 5 pi over 6 minus negative cosine of pi over 6. And this is my upper minus my lower, minus the red region of pi over 3. Well, this turns out to be cosine of 5 pi over 6 is negative radical 3 over 2, so this is radical 3 over 2. Wow. Messy handwriting. Minus a negative radical 3 over 2 minus pi over 3. And I put this all together, and two negatives make a positive. And I get the whole shaded region is equal to radical 3 minus pi over 3, which if you want to put this in your calculator, I get 0.685. And there we go. A little bit harder because of the trick that's involved. Okay. Today's the last lesson.